Okay, so here is the quiz on Unit 1, homeworks 5 through 9. We'll start with multiplying, part A there, 23 times 2 in base 5. So here's part A, going to multiply 23 times 2 in base 5. So 2 times 3 is 6, but in base 5 we're never going to see a 5 or more. So what is 6? 6 is carry 5 away, leaves 1 left over, right? Because in base 5, the carrying is always 5. So that's carry 5, leave 1. That's where the 6 goes. And then 2 times 2 is 4, add 1 is 5, but nope, never going to have a 5. That's 1, 0, isn't it? Carry 5, leaves 0. Because again, this carry here is 5. Whenever you carry in base 5, you're carrying 5, so that leaves 0 left over. 101 is the answer. Let's try B. 23 times... Oh, that's the same question. That's funny. So that one on B. Oh, actually, that's a divide one, isn't it? Yeah, so that's divide. Okay. So now we'll come over here on part B. And 23 divided by 2 base 5, so 2 goes into 23, all in base 5. So remember how we're supposed to do long division. We're supposed to take the number, this number that we're dividing into, and we're supposed to add them up. We're supposed to take 2 and 2 is 4. Now what is that? That's 2 2's. This is 1 times 2. This is 2 times 2. Supposed to add another 2, get 6. But remember, we're in base 5 here. This is all base 5. So 6 is actually 1, 1. You know, this represents 5, and 1 more is 6 in base 5. So it's 1, 1. What's that? That's 2 times 3. And now add another 2. 2 and 1 is 3. 1, 3. That's 2 times 4. So, oops, I didn't do that here. Let me write that a little better. So it's 1 times 2, 2 times 2, 3 times 2, and 4 times 2. There we go. So we've got this, 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 and this. So you always get your times tables ready when you're doing long division in a foreign base. So when you're doing long division in a foreign base, and how do we know to stop here? Because we're in base 5, so there's not going to be a 5 times 2, is there? In base 5, you're never going to see a 5, so there's not going to be a 5 times 2. So we just do 1 times 2, 2 times 2, 3 times 2, and 4 times 2, and we get the result. We just keep adding another 2 every time. See how we just added another 2 every time? And we have them all ready to go. Now, how does 2 go into 23? Well, 2 goes into 2 one time. That's easy. Bring down the 3. And 2 goes into 3 one time. Well, that was easy. I don't know why we did all those times tables. There we go. So the remainder is 1. The answer is the 11 on the top up here. And the remainder is 1. That was so easy, and I did all that work pretty much for nothing. All right, let's go on to part C. We're multiplying 32 times 22 base 6. Okay, here we go. Base 6 multiplication. 2 times 2 is 4. 2 times 3 is 6. Never going to have a 6 in base 6. That'll be 1, 0. Won't it? I'll just leave it there. I'll bring this 4 down. So it's 104. Okay, next column. Well, I don't know, is that confusing? I'll put that back where it was, I guess. So he's done. And now, the 2 times 2 is, now you add a 0. 2 times 2 is 4. 2 times 3 is 6, but 6 is 1, 0 in base 6. Add them up. 4, 4, 1, 1. 1, 1, 4, 4 is our answer. Let's do D here. we're dividing 143 base 5 divided by 3. So 143 divided by 3. And this is all base 5. So remember what we have to do whenever you're long dividing in a foreign base, even though it was for nothing last time, in general you gotta take 1 times 3, which is just going to be 3. Then you got to add another 3. You just keep adding this number over and over again. That'd be 6, but you can't have a 6 in base 5. This is all base 5. That's going to be 1, 1. This is base 5, right? Let me make sure. Yeah, base 5. It's going to be 1, 1. So that's 2 3s, isn't it? Right? We got that from 2 times 3. Right? 2 3s added up, made that. Then add another 3, and you get 14. That's 3 3s. And then add another 3, you get 7, but you can't have 7 in base 5. Carry 5 leaves 2, and then 1 and 1 makes 2. 2, 2, that's 4 3s, isn't it? So and that's as far as we need to go. 4 3s. What was this one? This one was 3 3s, 2 3s, and of course 1 3. We don't need to do 5 times 3, right? We did 1 times 3, 2 times 3, 3 times 3, 4 times 3. You don't need to do 5 in base 5. You're never going to see a 5. So we don't need to do 5. So you take that number you're dividing by, and you find all the times tables for that number. Up as far as you can go. In base 5, you're not going to have a 5, so we go up to 4. All right, so now we're ready to long divide the number. How many times does 3? 3 doesn't go into 1, but it goes into 14. How many times does 3 go into 14? You can see it right here. That's 3 times 3. So remember how you line these up? Put the 3 right there. 3 times 3. Let me get rid of this stuff. So 3 times 3 is 14. See how this comes in handy? 3 times 3 is 14. Subtract 0. Bring down the 3. How many times does 3 go into 3? 1 time. 0. So there's the remainder. And the answer is what's on the top there, 31. Remainder 0. All right, E that's another long division. 10 100. So 1E, so 10 100. 10 100 divided by 10, all base 2. Divided by 10, all base 2. Okay, what do we do? Actually, I think I'm going to skip it this time. This one's ready to go. All right, let me do the lineup thing. So 10 goes into 10 one time. That'd be 10, remainder 0. Bring down the 1. 10 doesn't go into 1, 0 times. Now bring down the 0. 10 goes into 10 one time. Bring down the 0. 10 goes into 0, 0 times. So there's the answer, if you can read it up there. 1011. So the answer is 1010, and the remainder is 0. It's kind of a weird one. Can you see this up here? 1010. And finally, F, 111. It's an F there. Times 110, base 2. 110, this is all base 2. Multiplication, here we go. 0, 0, 0, so 0 times all that stuff is just 0. That was easy. Base 2 stuff's kind of nice. Cross that one out, add a 0. Start with the next one. 1 times everything is easy. 1, 1, 0, 0, 1. And then, next column, add 2 zeros. He's done. Add 2 zeros. And now again, 1 times everything. So that's 1, 1, 0, 0, 1. Add them up. That's nice. So 0, 1, 2. Oh, base 2, you're never going to have a 2. Can't have that 2. Carry away 2 leaves 0 behind, right? When base 2, whenever you carry, you're carrying 2. So 1 and 1 makes 2. Can't have a 2. Carry away 2 leaves 0. This is 1. Right? These all add up to 1. 1 and 1. So there's my number 1, 1, 1, 0, 0, 1, 0. Base 2. So there's problem number 1. Problem number 2. So 19 minus x, write that as a related addition sentence. How can you say that same truth with adding? You can say 19 is 6 plus x, right? That's saying the same thing. If the difference between 19 and x is 6, then take that 6, add that difference, you'll equal 19. That's saying the same truth. Next one, round to the nearest hundred. So if you take 2, 6, 8, 3, which digit is in the hundreds place? This is the ones place, tens place, hundreds place. So this digit's in the hundreds place. So you find the spot you're supposed to round to. That's the hundred spot. Look 1 to the right. If the digit 1 to the right is 5 or more, round up so it becomes 2700. So 2683 is closer to 2700 than it is to 2600. That makes sense, doesn't it? 2700 above it, 2600 below it. Which one's it closer to? 2683 is closer to 2700. That's the nearest hundred. We circled the hundreds place, looked 1 to the right. If it was 5 or more, you go up and make it 100, 2700. Okay, so number 4, if a number is not divisible by 3, can it be divisible by 6? If you got some kind of number that is not divisible by 3, here, I suggest what makes these easier is just pick a number that makes it true. So what's a number that's not divisible by 3? Like 10, right? 3 does not go evenly. It goes in, but it would have a remainder, right? It doesn't go evenly into 10. Can 6 go into it evenly? No, 6 doesn't go into it evenly either. So if a number is not divisible by 3, can it be divisible by 6? No, it looks like no is probably the answer. I mean, I might just have picked a weird example, but probably not. Probably the answer is just no. In fact, that is the answer. And the reason is because if 6 divides into a number, then that number is made out of 6 times n. So that makes sense. Like if 3 goes into 12, right? If 6 goes into 12, which it does, it goes in there 2 times. Then 6 can be written. So if 6 goes into x, then that x, that number x, can be written as 6 times n. In this case, 6 times 2. I don't know if that's confusing for you. I'm not going to ask you these specifics on an exam as much as I'll just ask you if it's true or false. So this is the reason they're giving. It's because it's that is confusing wording, isn't it? So can it, if a number is not divisible by 3? I don't like all this stuff. This is fancy talk. But basically the answer is no, because if 3 doesn't go in, then 6 can't go in because 6 has a 3 in it. Yeah, that's our answer on that one. Let's move on. How about part B? If a number is not divisible by 6, can it be divisible by 3? So let's take a number that 6 does not go into. Like 6 does not go into 13, not evenly. So can 3 go in? No. But careful. Here's a case where my first no example is not the right one. Because here's another case. How about 6 does 6 go in Does 6 go into 9 evenly? No. But 3 goes into 9 evenly. So if a number is not divisible by 6, can it be divisible by 3? Yes. Yes, it can, because multiplying 3 by an odd number results in a number not divisible by 6. You see? Basically, if 6 does not go into a number, 3 may still go in because 3 is smaller. 3 is smaller than 6, so it may still go in. Again, I don't want you to worry so much about the words. I'm not going to ask you for all these weird words about odd number and all that stuff. Don't worry about that. But just know the basic idea. I will ask you true and false on the exam about the basic idea. So let me again reason the basic idea with you. If a number is not divisible by 6, right? If 6 does not go in, something like 9. 6 does not go evenly into 9. Could 3 go in? Like if 9 is a number that 6 doesn't go into, could 3 go in? Yes, it could, because 3 is smaller. 6 may not go in, but 3 could, because 3 is smaller. That's why it's a yes. So just know the yes or no, the true or false. Don't worry about all those words about why. Okay, so number 5 now. If a number is true or false, if a number is divisible by 6, this is the kind of thing I'll have on the on our exam. If a number is divisible by 6, then it is divisible by 2 and 3. So the best thing to do on these word ones where it's true and false is to try to just pick a number that might work. So if a number is divisible, it says, what's a number divisible by 6? Like 12, right? 12 is divisible by 6. 6 goes in there twice. Then 12, is divisible by 2 and 3. That's true. That's true. Now, just because you pick a true example doesn't mean it's always true. So so I'm going to put down true, but you could try to pick another number. You could try picking a few numbers, like 18 is divisible by 6, and 18 is also divisible by 2 and 3. Now, can you see that it's always going to be true? Because if 6 goes into something, if something's divisible by 6, divisible by 6, 6 is made out of 2 and 3. If 6 goes into it, of course 2 and 3 are going to go into it, right? All right, B. If a number is divisible by 2 and 3, then it is divisible by 6. So if 2 and 3 go into a number, then 6 goes in. Well, of course that's true, because 6 is just 2 and 3 put together, isn't it? So pick a number that's divisible by 2 and 3, like 12. Then 12 is divisible by 6. Yeah, that's true. Next one. If a number is divisible by 2 and 4, then it's divisible by 8. Let's pick a number divisible by 2 and 4. Like, how about 12 again? 12, is that divisible by 2? Does 2 go into 12 evenly? Yeah. Does 4 go into 12 evenly? Yeah. 12 is divisible by 8. Oh, no, it's not. 8 does not go into 12 evenly. It goes in once with a remainder of 4. Look at that. 12 is divisible by 2 and 4. But 12 is not divisible by 8, not divisible by 8. So that's false. Now, if you get false, you know for sure it's false. You don't even have to look any further. When we say true, we're saying always true. If something's true, it's always true. And so if you think something's true, you should probably test it with a few different numbers to raise your confidence that it's really always true. But if you get something false, you're done, right? You know it's not always true. It's a false statement. All right, let's do D. If a number is divisible by 8, then it is divisible by 2 and 4. Like 16 is divisible by 8. And is 16 divisible by 2 and 4? Yeah, that's true. Again, I got true, but I should probably test other numbers, or maybe just stop and think. If 8 goes into a number, it's divisible by 8. 8's made out of 2 and 4. That means 2 and 4 have to be able to go in as well. So that's going to be true. Last one, part E. If a number is divisible by 8, if and only if it's divisible by 2 and 4. If and only if is basically saying both C and D. See how they said the same thing in two different directions? C said, if it's divisible by 2 and 4, then it's divisible by 8. D said it the other way. If it's divisible by 8, then it's divisible by 2 and 4. Well, if and only if is saying both things. It's a way of saying both things. You're saying it's divisible by 8 if it's divisible by 2 and 4, and then vice versa, only if it's divisible by 2 and 4 is it divisible by 8. It's basically showing both directions. So did both directions work? No, this direction was false. That's not always true. One of those directions is false on that one. So that's kind of tricky. If you see the phrase if and only if, that phrase, you have A is true if and only if B is true. If you see that kind of phrase, that means both if A then B, and it also means if B then A. It means both directions. Why? Because A if B, so there's the if B then A, if B then A, and A only if B. So meaning A is true only if B. That means that way. That last one's a little trickier to see. Something's true, A is true only if B is true. Do you see that means A is going to be true only when B is true? So if you know A is true, then for sure B's got to be true. That's what. So the if implies that way. The only if implies this way. So when you see the phrase if and only if, it means both directions, and we already know that one of the directions was false, right? If it's divisible by 2 and 4, then by 8, that was false. The other direction was good. If it's divisible by 8, then it's divisible by 2 and 4. They're saying, are both directions with the 8 and the 2, 4 thing, are both good? No, one of them was false, so they're not both good. It's false. Right, number 6, find the prime factorization of 2205. So you take your calculator, start breaking. 5 goes in, right? So I'm going to use my calculator I've got right here too. So take 2205 and divide by 5. So I'm getting 5 times 441. Now what does 441 go in? I'll try dividing by 3. I'm getting 3 times 147. The 5 is done. The 3 is done. How about this one? Try to divide by 3 again. I'm getting 3 times 4. That's done. And 49, 7 times 7. So there it is. There's the breakdown. What do we end up having? 2 3s, a 5, and 2 7s. So there's the prime factorization of 2205. All right, let's try the next one. Test whether 105 is prime. Now that's a silly question. It ends in a 5, so of course not. Of course not. The answer is no. That's a really silly question. Make sure you know in general, though, that you, because they could, I'm going to give you a more tricky one on the exam. I don't know why it randomly selected that one. You might have a harder one. To answer it, you've got to start, number 1, you try dividing only primes. Remember? So they gave me too easy of a one. But what you would do in general is try dividing only primes. So that's 2, 3, 5, 7. What's the next prime? 11, 13, 17, etc. Now, how far do you have to go? You only need to try primes because remember, all the other numbers, the composites, are just composed out of primes. So if you just try dividing all the primes, you will have tried everything you need to try. You will have tried everything, really. And then stop at the square root of the number. So in our case, square root of 105 is 10 point something. And so we can stop at 10, meaning we only need to check 2, 3, 5, and 7. So if you just try 2, 3, and 5, and 7, and none of them go, is that prime? That would be well, this one's not prime because right away 5 goes into it, doesn't it? So that's how you test if a number's prime. Just test only try dividing by other primes and stop at the square root of the number. That's as far as you need to go. Okay, so here's the number 8, the Mr. Arborita thing again. Basically, they're asking us, find all the numbers that go into 100. So remember how this works? We take the 100, and we say, what multiplies? We're going to start with 1. 1 times 100. 2 times 50. 3 doesn't work. Use your calculator. Just 100 divided by 3 doesn't work. 4 times 25. 5 times 20. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 doesn't work. 10 times 10. And once you get to that number, that's the square root of the number, right? Square root of 100 is 10. You can stop, because anything after that would be a repeat of earlier numbers. You know what I mean? If I did 11, it wouldn't work. 12, go all the way to, I think 20 would be the next one. It'd be 20 times 5, which we've already got right here. So anything after the square root just repeats. So that's kind of like why we don't need to look any further than the square root for primes. It's the same thing here. We don't need to look any further than the square root to find all the numbers that are possible factors or divisors. So what are the answers? It's all these numbers. 1, 2, not 3, 4, 5, 10, and then 20, 25, 50, and 100. You don't list the 10 twice. So you just list all these numbers. It'd be 1, 2, 4 and 5. 4, 5, 1, 2, 4, 5, 10, 20, 25, 50, and 100. You don't have to put them in order from low to high. You can put them in any order. Just write them all out separated by commas. Those are all the possible numbers that go into 100 evenly. Let's try part B. So part B, now we're going to do the 20. So you take the 20, and you say what multiplies? We're going to start with 1, 2, 3 doesn't work, 4 times 5. What's the square root of 20, by the way? It's going to be 4 point something, right? It's as far as it goes. Square root of 20 is 4 point something. So I can stop right here. Anything after, so the next one would be 5 times 4, and that's a repeat. So we can stop right here. So what are all the numbers that go in? 1, 20, 2, 10, 4, 5. Those are all the numbers that divide evenly into 20. Let's go on to part C. So part C, 23. What goes into 23? Yeah, just 1 times 23. Nothing else, because it's a prime number. Nothing but 1 in itself go in. That was an easy one. All right, finally, part D, 144. So let's do 144. Start with 1, then 2, which is going to be 72. 3, I don't know about 3 as it, I'm going to use my calculator here. 144 divided by 3. I'm getting a 48. And then 4 is 36. And then 5 doesn't go. 6 is 24. 7 doesn't go. 8 is 18. 9, I think it's 16, 90, yeah, 9, 16. 10 doesn't go. 11 doesn't go. 12 times 12. Oh, and that's where we stop, huh? Because that's the square root of the number. Square root of 144 is 12, so we can stop at 12. Anything after that point is going to be a repeat. So there it is. So what are all the numbers? You just list them all. 1, 144, 2, 72, 3, 48, 4, 36, 6, 24, 8, 18, 9, 16, and 12. You just list 12 once. 12. There they are. All the numbers that divide evenly into 144. Okay, so now here's one more. I wanted to give you one more long division in base 7. So I'll bring it over here. 26. So we're going into 2142. Okay, so remember what we do when we do, and we're in base 7. Whenever we do long division, we have to take the number we're divided by over on the side of our paper. We have to go 26 times 1, that's clearly 26, and then we add another 26. This is all in base 7. So it's a little tricky. 6 and 6 is 12, which is carry 7, leave 5. Did you track with that? 6 and 6 made 12. I could do it more slowly here. 6 and 6 made 12. But you can't write 12. How do you do it? You carry, and when you carry in base 7, you're carrying 7. So that 1 I write up here is carrying away 7, leaving 5 behind. And 1, 2, 2 is 5, right? 1, 2, 2 adds up to 5. So 55, that's 26 times 2 in base 7. Now, add another 26. You just keep adding another 26 every time. So you have 26 times 1, we have 26 times 2. Now we're adding a third 26. We're in base 7. So here we go. 6 and 5 is 11. Can't have 11. Carry away 7, leaves 4 behind. 5 and 1 and 2, what's that? 8. Can't have 8. In base 7, you're never going to see a 7. Carry away 7, leaves 1 behind. So it's 1, 1, 4. That's 26 times 3. Now, add another 26. Here we go. 6 and 4 is 10. Can't have a 10 in base 7. Carry away 7, leaves 3. That's how we get the 10. 1, 1, 2, that's 4. And 1. 1, 4, 3. That's 26 times 4. And now, add another 26. 6 and 3 is 9. In base 7, you can't have 7 or more. Can't have a 9. So, carry away 7 leaves 2. When you carry 7 away from 9, it leaves 2. 1 and 4 is 5, and 2 is 7. Nope, can't have a 7 in base 7. Carry away 7 leaves 0. And 1 and 1 makes 2. 202. That's 26 times 5. And one more. Add another 26. Here we go. 6 and 2 is 8. No, we can't have 8 in base 7. Carry away 7 leaves 1, right? When you take 7 away from that 8, it leaves 1. 1 and 2 makes 3, and 2. 2, 3, 1. That's 26 times 6. And that's the last one. Why? Because we don't have to do 26 times 7. In base 7, you're never going to see a 7. So I've got 26 times 1, 26 times 2, 26 times 3, 26 times 4, 26 times 5, and 26 times 6. I got my times tables all ready to go. Now I can go back and do my long division problem. Put the lines in. Here we go. 26 doesn't go into 21, does it? Got to go all the way into 214, huh? 26 doesn't go into 21. How many times does it go into 214? There, 202, not 231. That's too much, right? 231 is too much. 202, that just fits into 214. That's what? 26 times 5. Put the 5 over the last digit of the number you're going into, the 214. So 5 times 26, right? 5 times 26 is 202 in base 7. Subtract. What does that leave us? That leaves us 2 and a 1. Bring down the 2. Now we want to go 26 into 122. How many times? There it is. 3 times. Not that. Not 4 times. 143 would be too much. But 114, that just fits under 122. So 3 times. 3 times 114, subtract. We're in base 7. So what does that leave? Well, we can't take 4 from 2, so we got to borrow. Make that a 1. And how many do you borrow when you're in base 7? 7, right? When you borrow or carry, you always borrow or carry the base amount. So when I borrow here, I'm bringing 7. So that'll make this 9, won't it? I brought 7 to the 2 that were already there. That made it 9. 9 minus 4 is 5, and the rest are zeros. So that's my remainder. So my answer is 53. Right from right here. My answer is 53, remainder 5. There we go.